NCERT Group 17 Elements, Class 12. Actually, we need to be very perfect in NCERT part. That's why I don't want to take any risk. So I am giving you as it is of NCERT. Fluorine, chlorine, bromine, iodine, and astatine are members of Group 17. These are collectively known as halogens. Halo means salt and gens means bond. That is salt producers. The halogens are highly reactive non-metallic elements. In this, fluorine is called superhalogen. Superhalogen fluorine. Like group 1 and 2, the elements of group 17 show great similarity among themselves. That much similarity is not found in the elements of other groups in the periodic table. Also, there is a regular gradation in the physical and chemical properties. This is the important line. Astatine is a radioactive element. Rest points you can very comfortably leave except these halogens. Then coming to occurrence. Fluorine and chlorine are fairly abundant while bromine and iodine are less so. Fluorine is present mainly as insoluble fluorides. Fluorospar, first question. Cryolite, next question. Fluorapatite. All these formulas are important. And small quantities are present in soil, river, water, plants, bones, and teeth of animals. Seawater contains chlorides, bromides, and iodides of sodium, potassium, and magnesium and calcium, but is mainly sodium chloride, about 2.5% bars. So, seawater is salty, na? That reason is all these salts and particularly sodium chloride. And sodium chloride is prepared from seawater only. The deposits of dried up seas contain these compounds: sodium chloride and carnate, KCl, MgCl to 6H2O. Certain forms of marine life contain iodine in their systems. Various seaweeds, for example, contain up to 0.5% of iodine, and chili saltpeter contains up to 0.2% of sodium iodate. Remember this question. Particular need purpose you can expect this question. Chili saltpeter contains sodium iodate, and seaweeds contains iodine. These are direct questions. Formulae: carnallite KCl MgCl to 6H2O, and cryolite Na3LF6, fluorospar CaF2, fluorapatite CH3PO4 taken twice CaF2. Must remember. This table, just we will see some important points of this table. See, atomic number, down the group increases. Atomic mass, down the group increases. Electronic configuration, same. Here you see first time d orbitals, here first time f orbitals, because of the some similarities, some differences you can expect. Covalent radius, down the group increases. Ionic radius, down the group increases, no exceptions. Ionization potential decreases, no exceptions. Electron gain enthalpy, this is the exception. And remaining, you can say chlorine, fluorine, bromine, iodine, we have discussed many number of times. Electronegativity 4, 3.2. This is one interesting one. In first year books, it is given 3.0. Here it is given 3.0. I think that's a small mistake. Bromine 3.0, iodine, and astatine. So down the group decreases. This is a controversy point. And it clearly says that delta H hydration. Hydration also decreases. Fluorine hydration is more. Melting point, if you see, fluorine is a gas, chlorine is a gas. So their melting points are less. Down the group increases. Regular point, boiling point increasing, regular point, density increasing, regular point. So no problem here. Distance, bond length increases, regular point, bond dissociation. It is interesting. 158 should be more actually, but it is coming here. So chlorine, bromine, fluorine, and iodine. Bond dissociation. The reason is due to small size and lone pair of electrons. Small size and lone pair of electrons is responsible for the fluorine less bond energy. Very important point. Its bond enthalpy is even less than hydrogen. So we compare with hydrogen also. Inert values, all positive, down the group decreasing. That means this is the strongest oxidizing agent comparatively with the remaining. And here it is mentioned about radioactive Pauling scale. Not much worrying factor. The trends of some of the atomic, physical, and chemical properties are discussed below. Electronic configuration, NS2 NP5. Nothing is required. I am not reading as it is. Atomic and ionic radii down the group increases, just now we have discussed. Ionization potential down the group decreases, we have discussed just now, regular trend. Electron gain enthalpy, fluorine and chlorine. Chlorine is greater than fluorine, just now we were discussing, the same points will be here. Nothing special to go with this, just see the table, that's enough. Electronegativity down the group decreases, given. Halogens have maximum negative electron gain enthalpy in the respective periods because they need only one electron. They have great nuclear charge, that's why it will be great. So, shall we go with these physical properties? Yeah, physical properties will complete in this video only, but then we will go with the chemical properties. See, halogens display smooth variations in their physical properties. Fluorine and chlorine are gases, bromine is liquid, and iodine is solid. Important point. Their melting and boiling point steadily increases. This point we have already discussed. All halogens are colored. This is due to absorption of radiations in visible region, which results in the excitation of outer electrons to higher energy level. By absorbing different quanta of radiation, they display different colors. Fluorine yellow, chlorine greenish yellow, bromine red, and iodine violet. You need to remember all this. See, actually, you can remember like this. VBGR colors, VBGYOR. If it absorbs violet, it appears yellow, exactly opposite. If it absorbs green, it appears red. If it absorbs blue, it appears orange. Appearing color is called complementary color. Fluorine appears yellow means it absorbs high energy violet radiation. Iodine appears violet means it takes low energy yellow radiation. Okay, now this point you need to remember. Fluorine and chlorine react with water, of course. Bromine and iodine are only sparingly soluble in water but are soluble in various organic solvents such as chloroform, carbon tetrachloride, carbon disulfide, blah blah blah, not required. One curious anomaly we noticed from table 7.8 is the smaller enthalpy dissociation of fluorine compared to Cl2. That is because of you see the order. A reason for the anomaly is the relatively large electron-electron repulsions in fluorine. That's why it is less than chlorine. That point we were discussing. All the electron gain enthalpy of fluorine is less electron, and fluorine is the strongest oxidizing agent. This is given because the bond dissociation energy is less and the hydration enthalpy is more. Actually, there will be 5 points, you see. If it want to be an oxidizing agent, first, if it is a solid, solid should turn into liquid, liquid should turn into gas, gas, this is F2, 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 and 2 F atoms should form. This is dissociation. Then gaining of electrons to form F minus, this is electron gain enthalpy. Then keeping this in water, that is hydration. Interesting point is, for fluorine, these two steps are not required because fluorine is already gas. Dissociation is endothermic, we need to give energy. And this is, of course, exothermic, but less amount of energy is released, electron affinity. And hydration is very high. So this is also exothermic. One step is endothermic, which is less energy required. Electron affinity, of course, less compared to chlorine, but hydration enthalpy is very high. So when you compare all these three values, because of high hydration enthalpy, fluorine is the strongest oxidizing agent. For chlorine, if you see, this point will be more, that is endothermic. Okay, now Cl2 to 2 Cl atoms, bond energy is more. So we need to give more energy in case of chlorine. Of course, chlorine plus electron gives rise to Cl minus, more electron affinity compared to fluorine. This is exothermic, this is also great. But when it comes to aqueous solution, that is hydration, that is again fluorine dominates here. It is exothermic but less than chlorine. So by considering all this, you can say fluorine is the strong oxidizing agent than chlorine. Okay, now chemical properties we'll discuss in another video. Thank you guys.